So welcome to Everyone Can Contribute to SLO. My name is Andrew Newdigate. I'm a distinguished engineer in the infrastructure department at GitLab.com. And
I'm Bob van Landuyt. I'm a backend engineer at the scalability team as part of infrastructure on GitLab.com.
Great. So GitLab has been working on its adoption of SLOs for several years, and we can break this down into two distinct phases. In the first phase, we were primarily focused on replacing our cause-based alerts with something more fit for purpose. The main stakeholders were SREs, and SREs also own the definitions of the SLIs, the SLOs, and the alerts. When we get an alert, it's handled by the SRE on call. And this approach has improved the coverage, the accuracy, and the recall of our alerts a great deal. I did a talk at SLOconf last year on this topic, and you can find it online if you look for it, or there's a link in the presentation. Just a quick explanation about how we structure our SLIs. So we apply a consistent structure to all our SLIs that we monitor on GitLab.com. And this structure has some quirks, but it works well for our purposes. And it's evolved over time and has some features that predate our SLO monitoring stack. At the highest level, on the left, we have an environment, and this is composed of multiple services. Moving to the middle, each service is composed of multiple components. And then finally, on the right, each component has up to 2 SLIs, both of which can be optional. A latency SLI, which we refer to as aptX, and an error SLI. Ideally, a component has both SLIs, but it's not always possible to measure both, which is why we make them optional. Both types of SLIs are currents or event-based. We don't use time-based SLIs mostly, and this makes aggregation much easier. We also include an RPS metric, or request per second, and this is for each component. And this is useful for abuse, anomaly detection, DDoS, long-term service growth, etc. Now, the main reason we separate latency and errors in our SLIs is historic, but we keep it because it often is a good signal to the cause of an alert. The types of issues that may lead to aptX SLO violations are often different from those that lead to error SLO violations. And knowing this at alert time can give us a jump start in finding the cause of the problem. From an alert budgeting perspective, we aggregate these SLIs together. So we had all of this beautiful service level data providing us with excellent information on the reliability and availability of all of our services. And we felt that there was much more that we could do with this as an organization. We also wanted the application development teams that own the features to own their SLIs. And if we could do this, we could use this to feed into our planning process for improving the quality of our features.
One of the difficulties we encountered when trying to identify ownership of features and metrics is the fact that GitLab is mostly a Rails monolith. We've got some separate services that are built by a single team, like our runner service or Gitly, but most people contributing to GitLab do it inside our Rails code base. So that's where most of our features live. Besides being easy to contribute to, it also makes installing and running GitLab easier for most common cases. GitLab.com runs as standard as possible, just on a lot more hardware. So the monolith isn't going to go away. During phase 1 of our SLO alerting rollout, we focused on setting SLOs for all requests to the monolith per service. But because we have different kinds of traffic being served by the same service, we didn't always have a clear view on the performance of lower traffic features that would be overshadowed by traffic for CI or other kinds of automated traffic. This is especially true for new teams that add features that take some time to gain adoptions. So teams themselves didn't really have a window to see how their features were performing on GitLab.com. To put the SLIs more into the hands of developers, we've built a simple API. We did this inside the Rails application for a first iteration, but we plan on expanding this for our other services as well. Not all requests are equal, and using this small API, developers and project managers can specify what makes up acceptable performance. This means that we can have a tighter duration target for Git authentication requests than we do for an API call made by the runner to pick up a new CI job. This results in 2 Prometheus counter, one for the total rate of requests and one for the success rate. The counters are labeled with what feature the request was for, and we can use this information to make different kinds of aggregations. We can then use this metrics in our metrics catalog. Next slide. When we add a new metrics to the catalog, we use the same DSL that Andrew described last year. As a result, we have SLIs defined by developers with input from product managers that will alert SREs when features aren't performing well according to what product managers have defined. For phase 2, we wanted to start aggregating these metrics using the feature label we added, so we could apply an SLO to teams. In the future, we hope to be able to alert teams directly when an SLO isn't met. This alert should fire much earlier than the service alerts because of the narrower scope of the metrics. For example, CI traffic handled by the API service wouldn't be included for the import team.
This slide shows how we aggregate our SLIs. This is made much easier by the fact that all of our SLIs are occurrence-based, so we don't have to deal with the complexity of mixing time-based and occurrence-based SLIs. Internally, we store each SLI for each period with 2 counters, good and total. It's only at display time that we turn this into a percentage. The same is true for our aggregated SLIs. They're composed of 2 counters. This makes aggregating very easy. The good counter is the sum of all the aggregated good counters, and the total is the same. This also works through multiple layers of aggregation, as we showed on the previous slide. So we can take multiple aggregations and aggregate them into a hierarchical chain.
Because we reused the framework for SLO alerting from phase 1, we get dashboard for free. This is a dashboard for a single group that shows the same SLIs, but only for features that they are working on. The dashboards are generated from the same code as the service dashboard, so they have the same panels, error ratio, app-tech success ratio, and the request rates. Because we also include the information in the logs, we can generate links that only show requests that did not meet SLO.
Now, one of the most dramatic changes to our error budgeting process was when our CTO decreed that our error budgets must have teeth. And this was the moment at which our error budgeting process changed from being just another input into our planning process, purely used as informational guidance, to being something much more contractual. And it gave teams the ability to carve out time to work on technical debt that they needed to address. So this slide shows our error budget report. It's reviewed weekly on our engineering allocation meeting, which incorporates elements of the SRE book's production meeting. The report contains rolling 28-day error budget information, each team's traffic share, as well as information about incidents with outstanding corrective actions and how these corrective actions are related to each team.
Every team now has an SLO of 99.95, the same as we set for GitLab.com. And since we report on that monthly, we can take a look back and see where budget was spent if we spent more than we should have. We can use the aggregation one level down to see which SLI was underperforming. This is currently still a manual process, but we hope to automate that in the future. So to summarize, we went from SLOs being the business of SREs only towards involving everyone at GitLab. Developers and product managers have been included by putting the SLI definition inside the application, where they can specify what is good and bad. These numbers can be aggregated by feature and by group and used to inform management. So it's clear we need to spend some more time working on performance and reliability. So it's clear when we need to spend some more time working on performance and reliability issues. Now everybody's contributing to our SLO.
And that's it. Thanks for your time. We'll be around in the Slack channel to answer any questions that you might have. Thank you very much.